again, we discussed in the other video that we want to minimize our extension and we want to maximize our angle. That way we'll have the less impact forces on our system when we load our patient. What we have here, if you can see up, we have a Stokes basket on the roof going into 2 individual pulleys. And we don't go to the tip of the aerial. What we do is we go back a couple rungs down to where the C-channel for the aerial is actually built and welded and rated. We don't want to go to our tip because that's a breakaway tip. It's only held by 4 bolts and we don't want to load that at all. So we go directly behind that. From there, we have our load cell up top. That way we can try to get some data on the exact impact forces that we're going to put onto this system. If you work your way down the aerial, what we have here is 2 anchor straps going down to essentially just change your directions. Coming off the aerial, again, we don't want to go to a rung or anything that moves. We're going to go to that structural member of the aerial. And then we're going to go down to another change of direction down here where we are tied directly to our outrigger. There's no impact forces that we're going to measure there, but we consider that very minimum. Most of the system is going to be where that change of direction up top is. From there, we're going to build our whole system, which we have, and we go into our twin tension rope system. So just remember, if you have a 200-pound load, each rope should hopefully carry 100 pounds, right? And so that's how that twin tension system works. And we have our simple 3-to-1 here with our capto devices. One of the biggest things we always say is get your positioning right. If you get closer and you minimize your extension, you should be good based on your manufacturer's recommendations. We don't use our aerial as a crane, and we don't build a 4-to-1 directly down, right, to lift up our load. We talked about that before. It adds, in some instances, double the amount of impact forces onto the system. We have our aerial shut off, and that's a very big importance. You don't want your aerial driver to get into the habit of wanting or being influenced to try to move that aerial. We don't move a live load at all with our aerial device. So we have our aerial shut off, and you want to make sure that's locked out and tagged out. So I have a bunch of firefighters here, and what we have here, we have this orange rope that's also going up, and that's just a tag line. That's going to guide this line away from the building and down to where we have to go. Here we have this system here. Our firefighters are going to pull on their mechanical advantage system that they built with the 3-to-1, and we have to lift that package up off of the roof. And again, this is if we have an elevated rescue, right? A worker down on the roof, something like that. Something you could do pretty simple. Remember, again, minimize your extension, maximize your angle, and limit the amount of impact forces on your system. So they're going to go ahead and haul. Another firefighter that's going to man the tag line. And we're going to initially, we're just taking tension out of that system. All right, so now when you get your package away from where your obstacles are, in this case, it's our roof, one of the things that we want to do is make sure that our guy on the tag line is pulling away from the building, right? Our firefighters took the captos out of the equation. They converted the system into a lowering system. So now all we have is just a bunch of change of directions going into our clutch. And remember, this is a twin tension system, and all of the weight is on the clutch. And so in a second here, our firefighter is going to lower this down. And again, that load split between the 2 clutches into the 2 lines. If you notice here, we look at our load cell. And so we have 175 pounds of force. And remember, we started with 137 pounds of force. And so that's why we don't do that 2-to-1 system. We are well within our safety factor here. We are in line, and if you notice, you look at your vectors, you want your lines in line with your aerial as best as possible. Utilize whatever anchors you have, hopefully in line with that. You want everything in line with the aerial, and it limits the amount of impact forces on the system. So our firefighter is going to go ahead and lower this load. And then slowly, you'll see our package come down. And again, as this is happening, we want to make sure that if we don't have to have a rescue tethered to that basket with our patient, we don't want that. We want to limit the amount of weight that we have on the system, and we want to limit the amount of extension we have on our aerial. And remember, with this twin tension system, one firefighter can do this by himself. And again, this is all about communication. All right, and when we get our package down to the ground, we're going to continue to lower. All right. One of the things we want to talk about here is this package that we have here. Again, this is a training Stokes basket. We don't have a mannequin we can put in it, but we have our bridle hooked up to our Stokes basket. The other thing we talk about here, we always say we want a double long tail bowline. That's in case we have rescuers tethered, but in reality, we don't want the rescuer attached to the system if we don't have to. But we always go with a double long tail bowline directly to the bridle. That's pretty much it. We'll see you on another episode of the Advanced Truck Operations Course.